Hi, my name is Hyungkyun Yu, and my student ID is 230-350-10361, and my email ID is y.hyungkyun@op.iitg.ac.in, and I'm in program Bachelor of Science Honors Data Science and AI, and course code is DA379, and course name is Internship 3, Term Project 3, and Trimester 9. And the title of the Term Project 3 is the Rule-Based Internal Talent Match Recommendations with Enterprise LLM Explanation. I present a practical people analytics system for internal IT backfill recommendation. The central question is simple. When a key employee leaves, who inside the company is the most suitable internal replacement? Instead of answering this question with intuition alone, I designed a rule-based match rate engine that transforms detailed employee survey data into ranked backfill recommendations. On top of that, I attached an enterprise LLM layer only for explanation so that HR and business leaders can understand why each candidate was ranked the way they were. The problem background. The business problem emerged in a Korean edtech company with a large and diverse IT workforce. The organization had many technical roles such as backend engineering, front-end engineering, data science, infrastructure, and technical project leadership. However, HR could not reliably identify internal substitutes by using only job title or department data. That is because modern technical work is much more granular. Two employees may belong to similar organizational units, but one may have strong data pipeline experience, while the other may specialize in application APIs or project leadership. Therefore, the project needed a more detailed, feature-based representation of employees. For this reason, the company collected a 91-question IT capability survey. The challenge was to convert that survey into a usable backfill recommendation engine. Project objective. The objective of the project was not to build a black box AI predictor. Instead, I aimed to build an interpretable, business-friendly recommendation system with three characteristics. First, the match rate itself had to be rule-based and transparent. Second, it had to integrate multiple business signals, not only technical skills, but also role history, project history, service ownership, competency group, and self-report consistency. Third, the final result had to be human readable, so I added an enterprise LLM explanation layer after the ranking stage. So, the system combines rule-based scoring with controlled LLM-based explanation. Tools and technologies used. For implementation and prototyping, I used Python as the main programming language. For data handling and inspection, I used Pandas. And for spreadsheet style export or checking, I used Excel compatible workflows such as OpenPyXL when needed. The web application side was built around Django templates, HTML, CSS, and JavaScript. MariaDB was used as the relational database because the survey responses were stored in structured tables such as submission, answer, item master, and personnel roster tables. For development, I worked mainly in Cursor and VS Code style environments. The LLM component was connected through an Enterprise LLM API, but only after privacy filtering. Importantly, the ranking model is a rule-based scoring engine designed for interpretability, data, and feature design. The input data comes from MariaDB tables that store survey submissions, item responses, and a personnel roster. From these tables, I build a structured profile for each employee. The most important attributes are main role, secondary role, 5-level role proficiency, technical skill levels, service experience, project experience, collaboration related items, and competency group, which follows the V1 to V6 hierarchy. An important design detail is the smaller V numbers indicate higher position. So V1 is very senior and V6 is entry-level employee. Another important point is that the 5-level survey scale is not ignored. The engine does not treat coverage alone as enough. When a target employee has a high level in a role or skill, a candidate with only a much lower level receives a lower score. Finally, because the survey is self-reported, I added a reliability calibration layer. It does not claim to know the true skill of a person. Instead, it slightly adjusts influence when responses show inconsistency, missingness, or suspiciously uniform extreme scoring. I'll explain how the match rate is calculated. The first component is role fit. This compares target and candidate across 4 directions. Target main role to candidate main role, target main role to candidate secondary role, target secondary role to candidate main role, and target secondary role to candidate secondary role. This was necessary because in real backfill, a candidate may still be a strong substitute even if the relevant role appears in the secondary role rather than the main role field. The second component is a skill depth fit. This compares the target's detailed survey-based skill profile with the candidate's profile and directly uses the 5-level scores. The third component is competency group fit. This uses the V1 to V6 hierarchy to reflect whether the candidate is at a plausible seniority distance from the target. The fourth and fifth components are service and project fit. Question 83 represents service life cycle experience, and question 84 represents project history. For project similarity, I deliberately keep the ranking rule base by using normalized project title token overlap and leadership indicators. This makes the ranking logic explainable and reproducible. The sixth component is collaboration fit, and the last component is the self-report reliability factor. These components are combined into a final match rate using weighted aggregation. The final output is a ranked list of candidates. So why is the Enterprise LLM attached? At this point, the ranking is already complete. This is extremely important. The Enterprise LLM does not decide who ranks first. It does not override the rule-based engine. It is used after ranking. Its purpose is to transform structured evidence into a readable Korean explanation. For example, why a candidate ranks above another candidate, whether the strength comes from the main role alignment or the sub-role alignment. Q83 and Q84 experience, competency group proximity, or a combination of these factors. To protect privacy, the LLM receives only sanitized evidence. Names, emails, employee numbers, raw organizations paths, URLs, and direct personal identifiers are removed before the API call. System architecture and frontend. The system architecture follows a simple but practical flow. The web frontend receives a target employee email and the requested number of recommendations. The Django backend validates the request and loads the target and candidate profiles from MariaDB. Then the rule-based match rate engine computes the ranking. After ranking, a privacy-filtered explanation request is sent to the Enterprise LLM API. Finally, the frontend displays the ranked candidates with match rate and readable explanation. The frontend is designed to be intuitive for HR users. It shows the target employee profile, skill, and project signals, and a ranked list of candidates with compact explanations. To conclude, this project contributes a practical people analytics system for internal IT backfill recommendation. Its key value is not a flashy black box model, but a disciplined combination of rule-based ranking, detailed survey-driven employee profiling, self-report reliability calibration, and enterprise LLM-based explanation. This approach is especially useful in corporate environments that require both interpretability and security. Thank you.